All right, so a few points on random generators. Um, I should even try to make something maybe, or I'll just go theoretical first at least. Um, I mean, in nature, you very rarely get the, um I mean, a straight random. It's like it's not happening. So what you usually get is the normal distribution, uh, and I'm going to show you that once I have rotated this canvas. Um, okay. Oops. So a normal distribution or a Gaussian looks is called a bell curve in English a lot of times, and it looks something like this. And so like and it's like 70% of all the samples will fall inside this range. So if it's the height of people, so over here would be like 2 standard deviations. This is 1 standard deviation, and so forth. Uh, and between 2 standard deviations, you get I think 90.
What's a standard deviation?
As a mathematical term for statistics, like most stuff. If, for instance, this is the height of people, so say I'm just making up numbers, but say that the average height of people is 170 centimeters, for instance. Then this curve will tell, like, how do I put this? Uh, so counting all these values, counting all these heights, you will get like that 70% of people are between like 155, for instance, and 192, and and then over here you have like I don't know 140 and 204. I don't know. So, but the point of it is that all value, not all values, but many values in nature, they distribute on this curve that looks the same always. So if you get, I mean, uh, like the average height of a certain kind of tree, for instance, it would be like most trees are like 4 meters, but 80% of the trees, or like whatever number is, fall between 3.2 and 5.5. So, and the curve, this normal distribution curve or like Gaussian curve, it looks the same all the time. So that's very useful when you, for instance, place assets. So if you have, for say, a tree, new layer, new color. Um, if you have a tree here, very good looking, and you want to place like small foliage assets for some reason with code, you want to place them like quite many here, a few over here, and yeah, maybe just one like over here. So that could work with the normal distribution too, and will look quite natural. Uh, if you do like perhaps an infection, or like natural looking phenomena, you want to use this. I mean, a straight random will look like you will get everything within this kind of evenly spread. But in nature, that doesn't happen. So it will all like bunch up and be quite dense in the center, and then we get like the medium dense, and then we get like sparse. And I will check inside here if we have a Gaussian. Let's make a blueprint. Because Gauss distribution. And also, another cool thing you can do is wander through a texture. I can't spell. I actually made a pretty cool random generator in Maya where I stepped in a 3D fractal to get the values, and then you get like really organic kind of shapes like this in your noise or your distribution. Let's see, construction script, Gauss. Make it has a Gauss distribution. Perhaps it's I'm not gonna do a completely I've been put off for doing unprepared demos a bit, but I mean, you could actually step if you make my first in Maya there was no Gaussian distribution function. There was just a random, so I can show you how I did. I just I drew a curve on a paper like this that looked cool to me, and then I made a step model like this in I know, a few steps, and then I made randoms, and I made yeah, I can show you this one. Let's do a random number, random float. Smaller or equal. Loop again. Promote. Let's do it 1D. Multiply this one by the float. Put the number. And let's set a static mesh component again.
Can you take that again a little bit louder?
All right, so now I'm just making a 1D loop to show this, how you can use random to select or make like more random stuff than a straight yeah, like a straight grid, so to speak.
It would help me if you like say a bit louder which nodes you create.
Yep.
Because when I look back at the video, sometimes it's really hard to see what
all right, cool.
is written.
Yep, thank you. So I'm in the construction script. Here's a random float, and what we'll do later is check if this is smaller than a threshold value. And here's our number of instances, or number of copies, n copies. And here I will just make a line of stuff. So make vector with an x location and make it transform, and add a static mesh, and for this one I will just add a cube like that, and I will place it out here. Frame it. Let's promote this one too. Distance. Put either, make it editable in the editor. Yeah. So here's a lot of cubes, the straight grid. But if I want to make like a more random feeling to it, I can use a probability number. So a random float will produce a number between 0 and 1. And if I want there to be like a 50% chance of this happening, I will promote this number. probability of a cube of a mesh. Make it general purpose. So, and then I will just place it over here. Place this guy here. So, and then branch, of course. So branch node. Like this. Compile, save. So what this means is that instead of just making a static mesh component every time, it will create this random number. If the random number is smaller or equal to our probability number, which is at the moment 0.5, it will go ahead and create the mesh, and if not, it will not do it. So let's look at it. So here we have the kind of teeth of a sailor, and if I decrease the probability, you will get less teeth, and if I increase it, it will get more. So this is like a very easy way to put some randomness into your thing. Um, I mean, just to make a transform variation too, let's make another random here. I'll just use this random float because I had the problem with the stream, but to make a predictable random series, you need to do the stream. I'm just for the I don't want to get stuck on that right now. So all right, so random float, and we do a multiplication with a maximum height. So let's do 2 meters for starters, and we do promote this one, and we call it max height, and we make it public or editable, and we input this into the C. So this would be, yeah, let's have a look. Now we get some random height to it, and you can change this. And like you see, when every time it calculates, it will get a different number. So the stream thing, I wish I had it in fresher memory. Anyway, but for this one, I mean, if you want to make a Gaussian distribution, like most of them are on the ground level and some are coming up, um, you would split this random and make, if you can't do it straight in Unreal, let's make a like a Gaussian distribution. One other thing you can do is to make an exponential function of it. So let's put a power node here and promote this exponent. I know I talked a bit about exponentiality the other day, and that's also something that exists in nature a lot. So with gravity or anything, I mean, if you're very close to something, you have a lot of gravity. If you move away, it just falls off quite, you know, exponentially. Exponent height. So to make a visual example of it, let's go here. Forgot to make it public. And I don't want it to be 0, so I start at 2. Or I start at 1, because that's linear. So like right here, big number. So now they're evenly spread from 2 to 20 meters up. But if we increase this exponent, all right, I need to put it in the, now I put an all, so 2000 times the set is huge. So I want to put the exponent before I put the amplitude in. So I want to do the exponent on the 0 to 1 number here, not on the actual uh, finished amplitude. So now what you get is you get that um, most of the guys are down there, and increasing the you get a sharper curve, so to speak. So most numbers would be small, and a few numbers, like the random numbers that are close to one, will get their full range. But you get this kind of exponential curve to it. So that's one thing. Um, I just have to make a 2D loop of this one. Okay, any questions on this?
Uh, what scenario is a typical use for this?
Uh, Probably if you're making like a freaky space station thing with you know, uh, or uh, if you're making like a perhaps a distant city or something and you don't want to paint it, you could do like a sort of a noise distribution. Um, I don't know. It could be. I mean, I used it just to make some really freaky abstract environments for like Trip the Game. Um, um, yeah, I mean, actually, anything. I don't know. If you're making like standard stuff, like regular world things, maybe it's cars in a parking lot, or I mean, yeah, could be anything or nothing.
Okay.
But I mean, to me, I started out as a like pure graphics artist, and then after maybe 10 years or something, um, not 10 years as pro, but like 10 years total, I started doing script in Maya. Um, and to me, that was like because I made this leg rig all the time, like I don't know if you had rigging, but some of you have know that stuff. But I mean, to make a foot or a leg that works or is easy to animate, you need to be able to lift the entire foot and have an IK that controls the whole leg and everything follows along.
Yeah,
And then
we
sometimes,
had an rigging
yeah, yeah,
course.
yeah. So then you mean you need to place like lots of groups or nulls in in a hierarchy, and you need like,
Mm.
lots of IKs and all that stuff. So I realized I do this like once every 2 months. I rig a character, uh, and every time I do it, I miss something that I don't realize from the start, and I start animating, and then I realize like, oh fuck, I forgot to connect this, up vector or like a forward vector to whatever, and I have to go back and fix it. And sometimes it's problem with the animation or whatever. So that was my first like automated script, and it was a pure automation. So what I did was uh, I had the script listener open in Maya, and I built the rig like step by step correctly once, and then my only like what I had to learn was to replace all the names, explicit names, with variables, and that was it. So that was my first script. But then when I learned like more programming, I realized that programming is when you really make the computer work for you. So so and of course, if you want to make like complex art, like nature uses seeds, and like universe is a pretty cool like self-organizing system. So to mimic that, a lot of times you will want to use a little bit of programming here and there. um, so now I made 1,000 cubes instead of 50, and it took like 0 point something seconds. So uh, it's quite useful. Um, yeah, I mean, copying this kind of stuff in viewport is not recommended. Because it calculates construction script stuff, calculates every every time you modify it. So if I try to move this one, let's make it smaller. It will recalculate all the time. So that's why if you have like 1,000 instances, it will do this whole code like every frame, and you don't want that. So let's make it smaller and move it.
It kind of looks like it's alive.
Yeah, and I mean, you could do animation. Uh, yeah, it's quite complex, but I just throw in the notion that if you want to animate instances, you use uh, a function called update instance transform. Um, update instance. Uh, yeah, they made some new stuff here on the instancing functions that I haven't tested. So batch update is probably a lot faster than this one. Uh, yeah. So this and what you have to do to update transform or instances is you have to click this one, make render state dirty, because if it's not marked dirty, it will not update the actual instance. Um, so yeah. So what? Oh, yeah. I won't go into super detail on this one, but uh, if you're updating transforms, you input a new transform, and you have your instance number, because the instances are not stored as meshes; they are stored as an index with a transform, and that's it. Um, all right. And I mean, to instead of using a random generator like this, I mean, you could use um, like I'm not sure how to sample a texture in here, but I guess you could do that. I mean, in shader, a lot of time you just sample a texture, like I did with the sign, um, with the sign function here. Oh yeah, the reason this one is not visible is because it's just like 1 pixel high, or like 2. Um, so it's actually in here. See if I can. Yeah, so you see, you get all these numbers here, and I mean this way, since it is just it's three like 2D functions. Um, this way you can get like super, because it's like 2K or something, or yeah, 2K times 2. So it's like high res on the curves, and it's like no unnecessary pixels on the height, because I don't store any info there. Um, and I mean, you could make combinations of like noise patterns into a texture, and use that to like drive random offsets in your shader. All right. Um, we have some more time, so we could actually do some random offsets in shader. Um, because there's been some questions on shaders too. And I mean, shaders is such a huge area, but you know, it's about getting comfortable in there, uh, and just maybe like start simple, and add more complex variations as you go. Um, and this one, just for a note, or I'll make a new recording actually.